Hey guys, welcome to Crown's Math. In this video we want to differentiate the following functions, and these functions are the trig functions. Okay, we want to differentiate the following trig functions. Now if you watch my previous video, I showed how to differentiate a trig function using first principle. I showed how to differentiate a sine function using first principle. I showed us also how to differentiate cos function, okay, using first principle, and also tan. Okay, so kindly watch that video, kindly watch my video to see how to differentiate a trig function using what? First principle. So recall that my d over dx is a notation for saying, okay, d sine x over dx, okay, means differentiating sine x we get what? Cos x, and if we differentiate cos x we have minus sine x. Okay, so we want to differentiate this interesting question functions. Now we have that our f of x, okay, we have that if f of x is sine g of x, okay, then my f prime of x is g prime of x cos g of x. So this formula works when we have sine g of x. This particular formula works for this. Okay, please do not mix this up. Okay, now if f of x is also cos g of x, then my f prime of x is equal to minus g prime of x sine g of x. Okay, so this is g prime of x times sine g of x. This is sine of g of x. Okay, so also if my f of x is equal to tan g of x, then my f prime of x is equal to g prime of x sec square g of x. Okay, and this sec square means sec of x, sec of g of x all square. So it's something like this. Whenever I say sec square g of x, this means sec g of x, okay, all square. So that is just a notation for it. Okay, so let's go on with this. Let's solve this. So the first question is f of x is equal to sine 3x plus 1. So we have our f of x is equal to sine 3x plus 1. Now using the formula says that, okay, first of all, before we use the formula, what is our g of x? Our g of x in question is 3x plus 1. So this means my g prime of x will be what? Will be 3. So now if we now find our f prime of x using the formula, it is g prime of x times cos g of x. So my g prime of x is what? 3 cos, what is my g of x? 3x plus 1. So this is just it. Okay, very simple. Now for the second one, the second one looks interesting. Do you know why? Because we have x times cos 2x. Okay, now x is a function of x multiplying another function of x, cos 2x. So let's solve this. So we have this as x cos 2x. So this is f of x equal to x cos 2x. So when we have a function multiplying another function, we use what? The product rule. And the product rule says that, let me take this to be my u and this my v. So the product rule says that my u dv, okay, plus my v du, we have u dv dx plus v du dx. Okay, now here my u is equal to x, so therefore my du dx is equal to 1, and my v is equal to cos 2x. Okay, my v here is equal to cos 2x. Remember, our f of x is given as x cos 2x. So my f prime of x, we will not use this formula to solve it. We will not use this formula to solve it. We are not going to use this formula. We only use this formula if only the function cos g of x is given. That is, assuming there was nothing like x, it was only cos 2x, we can use this formula. Here we are using this. Here we are going to use product rule to solve this, but we are still going to apply that formula. Okay, so here this time around my v is what? Cos 2x. Okay, that is where I'm going to use that formula. I'm going to use that formula to solve this. Now, to differentiate cos 2x, remember that formula. Here I can now call my 2x to be what? My 2, let's say this 2x is what? Is g of x, right? So I can say my g of x is cos 2 is my g of x is 2x. So therefore my g prime of x is equal to what? My g prime of x will be 2. Okay, my g prime of x will be 2. So my dv dx will be what? Will be g prime of x. Okay, it will be g prime of x. It will be, sorry, not g prime of x, it will be minus g prime of x sine g of x. Okay, so this will be equal to minus 2 sine 2x. Okay, so that's my dv dx. Okay, because I'm differentiating only cos 2x. Okay, now I've gotten my dv dx, so I now apply by what? My product rule. Now what is my u? My u in question is x, right? So this is x. Now what is my dv dx? My dv dx is minus 2 sine 2x. Okay, plus what is my v? My v in question is cos 2x. Okay, cos 2x, sorry. Now what is my du dx? My du dx is 1, so times 1. So if we simplify this, I have this as minus 2x sine 2x, okay, plus cos 2x. So this is our answer. So this is what we have here. So therefore f prime of x is equal to this, okay, using product rule. Please, I hope you're not confused how I solve this, because here we have x multiplying cos 2x, so we are using what? Product rule, because we have a function multiplying a function. Here I made x to be u and make this one to be v. Using my product rule, u is equal to x and my v is equal to what? Cos 2x. So my g of x, my sorry, not g of x, my du dx is 1. If you differentiate u respect to x, you have 1. And if I differentiate the v with respect to x, I have minus 2 sine 2x. How did I get this minus 2 sine 2x? Recall that my formula says if I have a function, if the function is of this form, cos g of x, so I have cos 2x. So if I'm differentiating cos 2x, okay, I use that formula. So here I have to identify my my g of x inside cos 2x. So my g of x is what? 2x. So my g prime of x will be 2. Okay, now using the formula, if I have cos g of x, I'll have that minus g prime of x sine g of x. That's what I did here. So minus g prime of x sine gx. Okay, so this will be minus, why is my g prime of x? 2. So this will be minus 2 sine, what is gx? Gx is 2x, right? So this will be 2x. So now I gather all informations and use it to solve my product rule. So this is my x, this is my dv dx, plus this is my v, and this is my du dx. So this is your answer. So the last not the last one, actually the next one is tan x. Okay, I want to differentiate tan x. So my f prime of x is equal to tan x, no, sorry, my f of x is equal to tan x. Okay, now I want to differentiate tan x, so I'm going to I'm going to do something here. Now recall that my tan x is what? Sine x over what? Cos x. Okay, now I have a function of x dividing another function of x, right? So I can use my what? My product, my quotient rule. So I can call this my u and I call this my what? My v. Okay, now using my quotient rule, recall that the quotient rule is given as v du dx minus u dv dx all over what? V square. Okay, now what is my u in question is what? Sine x, and my v in question is what? Cos x, right? So my du dx is equal to what? If you differentiate sine x, you get what? Cos x. Remember what I said before, if you differentiate sine, you get cos, and if you differentiate cos x, that is dv dx, you have what? Minus sine x. So I'm going to use this to solve this. So this is equal to, now v is what? Cos x, right? So cos x, okay, times, what is my du dx? My du dx is also what? Cos x. So this will be cos x. Okay, let me use a new sheet for that. So let's go again. So this will be what? Cos x. Okay, my du dx is what? Cos x, minus my u here is what? Sin x. Okay, and my dv dx is minus sin x all over my v square. Remember, my v is cos x, right? So my v square is cos x all square, right? Now I can say this is the same thing as cos square x. These are the same thing. These two are just the same thing. Okay, so I write this as cos square x. Now the same thing here, cos x times cos x is cos x all square, right? Which is the same thing as cos square x. So this is equal to cos square x minus, now I can't maintain this minus. Do you know why? Because there is a minus sign here, so these two are multiplying, so I have sine square x. Now this minus times minus will give us what? Plus. So I have sine square x all over what? Cos square x. Beautiful. So recall our identity. Now recall that cos square x plus sine square x is equal to 1 from our identity, from trig identity. Whenever we have cos square x plus sine square x, the result is equal to what? 1. So we have this as 1 all over cos square x. Okay, so I can also write this as 1 over cos x all square. Okay, this is something as 1 over cos x all square. This also 1 over cos x give us what? Sec x. Okay, 1 over cos x is equal to what? Sec x. So we write this as what? Sec x. Now that is for 1 over cos x. Now we now put our all what? Square. Now remember that when I say this is all square, it's something as saying sec square what? X. So therefore, whenever we differentiate tan x, our result is what? Sec square what? X. Okay, and finally we have f of x is equal to 5 tan 5x square plus 4x. Okay, we have tan 5x square plus 4x. Now we are not going to use the same way we differentiate tan x to get this. Okay, here I just wanted to show you how to differentiate tan x using quotient rule. So here we are going to apply that rule. We are going to apply the previous rule. Okay, the rule I gave here. If f of x is tan g of x, then my f prime of x is g prime of x sec square g of x. Okay, so I'm going to apply that rule. You can also try using quotient rule to solve this. Using quotient rule to solve sine 5x square plus 4x all over cos 5x square plus 4x. You can also use quotient rule and try this and see if it will give you the same results. Okay, you can also use quotient rule and try it. Mind you, you're not just only going to apply quotient rule, you're also going to apply chain rule inside this, so it's going to be a long work. Okay, that's why the formula comes in, to make the work easier. So differentiating this, remember my g of x here, remember reason I'm applying this rule is because I only have the function tan g of x. I do not have another function multiplying it. Okay, just like when we had x cos 2x. Okay, so we're having two functions multiplying the same. Yeah, I only have one function tan g of x, so I can apply this rule, right? So my g of x is what? 5x squared plus 4x. So my g prime of x is equal to, this will be 10x plus 4. So applying that rule, I have 10x plus 4 times, that is for my f prime of x, sorry, this will be 10x plus 4 times 6 square. Now what is my g of x? My g of x is what? 5x squared plus 4x. Very simple. That's your answer. You can actually use quotient rule and see if this will give you this. Thank you very much for watching this video. Please kindly subscribe. Thank you, and share to your friends. Thank you very much.